Hi, this is Mr. Max. So in this video, I'm going to look at the inverse trig function, namely we'll look at the sine function. So the graph here shows the general periodic sine function as it would appear, and I say it's periodic because it goes on and on and on. I only use the interval between minus 2 pi radians or minus 360 degrees all the way up to 2 pi radians or 360 degrees. So this wave is going to repeat itself as you go. So this is a function. If you do a vertical line test, it's going to be a function. But what is important is when we do the horizontal line test. When we do the horizontal line test in any function, you realize that this becomes a many-to-one function. So its inverse will not be a function. So in order for us to make the inverse of the sine function a function, we need to look at the domain and we need to restrict the domain. So there are many conventional ones that we can use, but we're going to specifically look at minus half pi radians to half pi radians. That means from minus 90 degrees to 90 degrees. That is the interval that we are going to use. Alright, so when you see y equals 2, it means that you are now talking about y is the inverse of sine x. Right. So let's look at a few diagrams that it's very important for you to look at, especially as relate to special angles. Okay, although there are many ways to restrict the domain in order to obtain a one-to-one function, the following is the conventional interval that is used. The interval from minus 90 degrees to 90 degrees. That means in the first quadrant as well as in the fourth quadrant. Take note that in the fourth quadrant you're going to have a negative angle. So this is the domain that we are going to use, and the principal value or interval value that we always refer to are this between minus 90 and 90. Remember, if you were to punch on your calculator, like for example the inverse sine of x or arc sine, it only gives you one solution. For example, the inverse of 0 sine arc sine of 0.5, which is 30 degrees. 0.5 is a line that goes somewhere around here, and that angle will be about 90 degrees or 30 degrees rather. So this is the interval that we use, and if you play around and you punch on your calculator the inverse of, let's suppose, make it 1, you are going to realize you're going to get a 90-degree angle. So we're going to take this part of the sine curve and we're going to find the inverse of this. Now remember, for something to have the inverse, we are going to talk about an identity line. But I just want to bring it some few information here. The range, as you can see, of the function is between 1 and negative 1 inclusive. Then the domain is from between minus pi half radians to half pi radians, or minus 90 degrees to 90 degrees. So this is the conventional one that we are going to use when we talk about the sine curve and finding the inverse of the function. Right, so in this particular slide, you have the graph, we have the inverse. So I brought the graph back. So when we want to find the inverse, we're going to bring in a line, and that line is the line y equals to x. And any function, if you want to draw its inverse, it's going to be symmetrical. It's going to be a reflection about this line y equals to x. So that means the line that we're looking for is going to be like that, and you can see each point is exactly the same distance as the green curve is away from the red curve. So the inverse of the function is, or the inverse of the sine curve will take that particular shape. So you can just go around by swapping the coordinates. In order for you, if you have this on a graph, whatever this coordinate was on the green, you swap it in order to find the one on the red, for example. But the very important point is that the domain is always the set of x values and the range is always the set of y values. As you will see, I'm going to bring in that particular graph in now. So here you have the inverse sine curve. As you can see, the coordinates swapped around. Now you're going to have your new domain, or your range first, is going to be between 90 degrees and minus 90 degrees, or pi upon 2 radians, or minus pi upon 2 radians. And the domain is going to be between -1 and 1 inclusive. So this is the inverse of the sine curve for that particular domain, that restriction that we had on the domain. This is very important. You should always remember it. There are some special angles that we can find between -1 and 1, of whose inverses we can find between -1 and 1. And we're going to have a look at that very shortly. So when I say special angles, I'm referring to sine of 45 degrees, or pi upon 4 radians, sine of 30 degrees, or pi upon 6 radians, and the sine of 60 degrees, which is pi upon 3 radians. In fact, when you have this particular angles, you should be able to use and calculate problems without using a calculator. So let me bring in an isosceles right angle triangle. So if I make this unit to be 1, and this is also going to be 1, because isosceles triangles dictate that these two sides will be equal, and we know that angle there and the angle here will be equal, base angles of an isosceles triangle, which is pi upon 4, or 45 degrees. In order for us to find the hypotenuse, we have to use Pythagoras theorem. And we remember that when you find the longer side, you add the sum of the squares of the two shorter sides and take the root. So we're going to leave it in set form. So when I'm asking you to find the sine of 45 degrees, it's going to be nothing but 1 upon the square root of 2. Right, since we don't like to leave our answers as 1 upon square root of 2, you should always try to rationalize the denominator by multiplying throughout by root 2. Leaving your answer as 1 upon root 2 also is exactly the same as root 2 upon 2. Another triangle I'm going to bring in is an equilateral triangle. So what I'm doing with this equilateral triangle, I'm going to drop a perpendicular. And I'm creating a 30, 60, 90 degree triangle here on both sides. So I have got two congruent triangles. But I'm very interested in this particular one here. So in order for us to find that height there of the triangle, we use Pythagoras again. Since we are looking for a short side, we're going to take the square of the longer side minus the square of one of the short sides. And that gives us that distance there is root 3. So we can now calculate the sine of 30 degrees and the sine of 60 degrees, or the sine of pi upon 6 radians and the sine of pi upon 3 radians. So when your problem is given in radians, you should always give your answer in radians. So when you look at the sine of 30 degrees, it's that distance which is opposite to 30 degrees, which is 1 unit, upon the hypotenuse, which is 2. When you look at the sine of 60 degrees, it's going to be root 3 upon 2. So these are the special angles that we're going to work with, and we're going to bring in some problems and try to solve them accordingly. So I have got one here. It says use the special angles, and without using a calculator, write down in degrees the value of inverse sine of -1 half. So what does that mean? It means the angle whose sine is -1/2. And remember, we have that domain between -90 degrees and 90 degrees respectively. That is what we call the principal value interval. So we also know from looking at this that we're going to deal with a negative angle, which will be in the 4th quadrant. So if I bring my triangle back and I just want to see what that angle will be, where I have 1 upon 2, then I have to talk about this 30 degrees here, or the pi upon 6 radians. But then I'm not really interested in a negative value, because I know that the direction will be negative. It will be in the 4th quadrant, so that angle that I'm going to refer to will be minus 30 degrees, or minus pi upon 6 radians. So the inverse sine of -1/2 is equal to minus 30 degrees. As simple as that. The red arrows indicate the opposite over the hypotenuse, and that is how you determine the sine function, or the sine ratio. Let's look at the other two. You can pause the video here and also try to solve them yourself. Just remember that you must bring in those special diagrams for you every time. Don't have to study the diagrams by heart, but you should be able to quickly draw these diagrams. So I have here the inverse sine of minus 1 upon root 2. That also then means sine x is equal to minus 1 upon root 2. Bringing in my triangle, because I'm dealing with root 2, I have to use this isosceles triangle here. So the angle that I'm going to look for will be a negative angle because of that negative there. So I'm going to deal with nothing but pi upon 4 radians, or negative pi upon 4 radians, or negative 45 degrees, which is the answer to that solution here. Do you perhaps know what the answer would be for this one here? Well, if you're right, it should be exactly 45 degrees. But let's look at it anyway. So we are talking about the first quadrant here, and we are looking for a positive direction. So again, when you look at 45, you have got a 1 upon root 2 sine of 1 upon root 2, sine is opposite over the hypotenuse. The angle has to be 45 degrees, or pi upon 4 radians. So we're going to use that information, and we're just going to bring in two more equations. We're going to extend a little bit on what we have learned so far. So I brought back my 30, 60, 90 degree triangle, so to speak, with all the measurements and the angles. And we're now supposed to solve this equation. So it's the same concept here. It just means that when you want to find the sine of which angle gives you that, you can rewrite it as that. So 4x to the power 4 plus x squared is equal to the sine of this particular angle. But what is the ratio there? So when you go again back to your triangle, you realize that it's nothing but 1 upon 2, because there is where pi over 6 radius is. So we're going to replace that sine of 1 upon 6 radians with 1/2. And from here it becomes an equation that you should be able to solve. And when you come to this part, you should realize you're dealing with a hidden quadratic. There are many ways you can solve this, but I like to let that x squared equals to some k, and I then change my quadratic to 8k squared plus 2k minus 1 equals to 0, which I can effectively factorize, and it should give me 4k minus 1 times 2k plus 1 equals to 0. So either 1 is going to be k is going to equal 1 over 0.4, or k will equal to negative 1/2. But remember, I'm not calculating k here. I'm actually looking for x squared. So bringing x squared in means I must take the square root, and it's going to be two values. But if I look at this one here, I'm going to have a negative 1 over 2. The square root of a negative number does not exist. Therefore, I'm not going to take this answer. I'm going to reject this one. It's invalid, so I'm only going to use x squared equals to 1 over 4. So x is going to be plus or minus square root of 1 over 4. Square root of 1 over 4 is 1/2, or negative 1/2. And these are the two solutions to that particular equation. I've got one more that I would want you to try. Pause the video. It is not a very long one. In fact, it is a little bit shorter than the previous one. Think of your diagrams, and then you can think about doing that. But maybe you should first stop and remember that very important thing, and that is subscribe to the channel if you have not done so. And then there is a notification bell which you should click, so that every time when I upload videos, then you can get a notification. I'm also going to do the cosine and the tangent one. Right, so looking at this particular equation, so I'm bringing in this triangle. So I've got the inverse sine of 3x is equal to that particular angle there, which is a negative angle. So that means we're dealing with sine of that angle should give us the 3x. But then we know when we look upon our pi upon 3, we know that it's going to be root 3 upon 2, but it should be negative root 3 upon 2. So now I'm simply dealing with this linear equation. That means I must find the value of x. There are many ways you can find the value of x. I go and multiply throughout by negative 2 to give me negative 6x equals to root 3, and then I divide throughout by negative 6. Therefore, x is equal to negative and root 3 upon 6. Stand by for the other two videos that I'm going to upload on the trig, inverse trig functions, namely the cosine function as well as the tangent function.